Next question is question number 8. Figure 3.11 shows the velocity time graph of a particle of mass 100 gram moving in a straight line. Calculate the force acting on the particle. Acceleration equals to slope of Vt graph. Here we are supposed to find the force. Now you know the force has a formula of mass into acceleration. Now mass is given to us, whereas acceleration we are supposed to find from the slope of the graph. So let us go to the solution. Okay, coming to the solution, question number 8. The slope of a velocity time graph gives the value of acceleration. Here slope equals to 20 upon 5. Here we have taken the just 1 point. We can take 2 points also, but here we have taken just 1 point, which is given in the question, 20 and 5. So 20 upon 5 will give me 4 meter per second square. Since the acceleration is uniform, therefore we have just taken 1 point. Or acceleration equals to 4 meter per second square. Now using the formula for force, which is mass into acceleration, given mass is 100 gram, that means 0.1 kg. I hope you understood this. This comes because 100 upon 1000. We are converting gram into kilogram. Now force will be equal to 0.1 multiplied by 4, which gives me 0.4 Newton. This is how we are supposed to do number 8. Now we can go to the next question, which is question number 9. Well, coming to the next question, question number 9. A force acts for 0.1 seconds and on a body of mass 2 kg initially at rest. The force is then withdrawn and the body moves with a velocity of 2 meter per second. Find the magnitude of force. It is somewhat like number 7, but I don't think so it is so complicated as number 7. So let us try to do number 9. We have come to the solution of number 9. Time given to us is 0.1 second. Initial velocity is 0. Mass is 2 kg. 2.0 means 2 kg, whereas the final velocity is 2 meter per second. Here we are supposed to find the force. So acceleration equals to v minus u upon t, which is 2 meter per second minus 0 upon 0.1 second. So after calculating, we shall get 20 meter per second square. I hope you understood the cancellation and the calculation part. Then using the formula for force equals to mass into acceleration, which gives me 2 kg into 20 meter per second square, which is 40 Newton. This is how we are supposed to do question number 9. Now let us go to question number 10. Question number 10 reads as: a cricket ball of mass 100 gram moving at a speed of 30 meter per second is brought to rest by a player in 0.03 seconds. Find the average force applied by the player. So this is a retarding force. That means a force which is stopping an object. So let us try to solve this. So the mass given to us was 100 gram, which is 100 upon 1000 gives me 1 upon 10 kilogram. Initial velocity was given 30 meter per second. Since the body comes to rest, so the final velocity is 0. Time equals to 0.03 second. So here we are supposed to find the force. Now to find the force, we need two things, as you all know, which is mass and acceleration. From number 8, we are doing the same problem in a different way. So we are finding force. And to calculate force, we need two different things, that is mass and acceleration. So here we are supposed to calculate the acceleration using the formula A equals to v minus u upon t. So which is the first equation of motion also, v equals to u plus at. So using the formula A equals to v minus u upon t, and then replacing the values of v, u and t, we are getting A equals to 0 minus 30 meter per second upon 0.03 seconds. Now we have done the calculation. I have removed the points here 2 times. The point has been removed 2 times, hence this 100 comes here. Then we can cancel 3 1 times 3, and 3 10 times is 30. So 10 into 100 is giving me, 10 into 100 is giving me 1000 with a minus sign. So acceleration is minus 1000 meter per second square. So F equals to m into a. So F equals to 1 upon 10 kg into minus 1000 meter per second square. Hence I am getting force equals to minus 100 Newton, but there is no negative sign or no minus sign in your book. This minus sign shows this force is acting opposite to the direction of the motion. That means this force is stopping the motion. Hence this kind of force is known as retarding force, or I can write retarding force equals to 100 Newton. So I hope you understood number 10. Please read question number 11 and try to do it by yourself. Okay, let us go to question number 11. I have done half and I would like you all to continue from where I have left. Okay, reading question number 11. A car of mass 480 kg moving at a speed of 54 km per hour is stopped by applying brakes. It's same as number 10. Initial velocity is given, the final velocity is 0, the mass is given, and time is also given. So you are supposed to calculate the force applied by the brakes. So F equals to m into a. Mass is given, a we have to calculate from the formula. A equals to v minus u upon t. So let us see. I have done half. Okay, given mass is 480 kg, initial velocity is 54 km per hour, which I have converted to meter per second. Now please don't ask me where does this come from. We have done so many times, right? We are converting kilometer per hour into meter per second. If you don't know where does it come from, that means you need to study very hard, right? You need to go back to chapter number 2 and then start studying. So v equals to 0, final velocity equals to 0, and time equals to 10 seconds. So using this data, please calculate the force. Try to do it by yourself.